Is continue on learning about exponent and log word problems. So there's two things you guys need to have for this. Either copy this down and you're going to fill in the blanks as I go along, or you could print this out. This is all posted up on Google Classroom. As well as, now you may already have this printed out from another day, but it was a packet called Exponential and Log Word Problems. We did the first half of it. We're going to do the second half of it today. I did post it up. If you want to just print out the last page, basically, the last 2 pages, that's what we're going to finish up today. So let's take a look at this first one. Now, again, take good notes on this. We either print it out or very meticulously write this down. What you're going to notice is number 1 here is exponential growth and decay formula. And this is the formula that our first quiz was based on, the one we took this week. A of t equals a sub 0, 1 plus minus r to the t over k. And I want to run through what those mean again. Okay, so a of t is the amount over time. So what we end up with, or the final answer. Make that look better, more like an M. A sub 0, the thing in front of the parenthesis, is always the original or current amount, depends on the way they word it in the question. R is our rate. And T, obviously, is time. And what did the denominator stand for, or this K? That was anytime they said the word every, right? Or they said how long something took to double, or how long it took to half-life. Right, that was the K. Now, we're essentially using the same formula, but we're going to tweak it a little bit for compound interest. And you're going to notice this is our new formula now we're going to focus on this week. It's extremely similar to this one with one big change. All right, first thing, A of t means exactly the same thing, amount over time. So the answer, or what we end up with. A sub 0 still means the same thing, original amount. Okay? R is still the rate. Now what I want you to notice is the difference is in the original one we did plus minus, because sometimes things are increasing, sometimes things are decreasing. But interest means you're always gaining. So this formula will always be a plus sign. T is still time. Okay. Now, instead of a K or an every, there's N's here. And that's where the word compound comes in. This is the number of times compounding. And we're going to focus on what that means real quick. All right. So I want to shift down a little bit now. It says, how much money will you have after 5 years if you invest $1,000 at a rate of 4% compounded? Soon as you see the word compounded, it means we're using this new formula. So it's the compound formula. And we want to come up with this annually, right? If they say it's an annual event, how many times a year is that? And this would be the number 1. That means N would equal 1. So I'm going to go to my formula. How much money are we starting with? $1,000. Okay? Parenthesis 1 plus, the rate is 4%, so you're going to change 4% into a decimal, right? Now, 4%, but see here how it's being compounded? You have to take that 4% and divide it by 1, because it's annually. That's our N. Then the exponent is going to be N times the time. So N is 1, and time is 5 years. Voila! All right, that's what we're going to plug into our calculators. Now, anything divided by 1 is just 1, so I'm not going to put that in. Oops. I'll go to my calculator and type in 1,000. 1 plus 0.04 divided by 1, raised to, what's 1 times 5? 5. Okay, now it's money, so I'm going to round to the nearest cent. So I end up with $1,216.65. So that's annually. Now, biannually. How many times a year do you think that is? Or how many wheels does a bicycle have? Right? 2. So when we do it this time, we're going to make n equals 2. So we're starting with 1,000. 1 plus, it's still 4%, but this time we're going to divide by 2 and do 2 times 5 and see what happens. All right, so we do 1,000. 1 plus the fraction button, 0.04 over 2. Raise to the, what's 2 times 5? So we're going to raise it to the 10. So we end up with 1218.99. Now check it out. I did it a few more times a year, right? I made a little more money. So let me explain what's happening here. Let's say you go to the bank and they're offering you 4% interest. And they said, we'll give it to you once a year. That's how much money you would make. But if there's a sign hanging on the window saying, hey, we'll give it to you biannually, meaning they'll take the 4% and split it up into 2 payments, right? Look, you make a little bit more money. So let's see what happens here. All right, now this thing is advertising. It'll do it quarterly. How many times a year is quarterly? And that's 4 times a year. So this time we're going to take the 4% and chop it up 4 times and do it 4 times. So I'm going to do 1,000. Now, what do you guys think is going to happen to the amount? The trend holds, we should end up with a little bit more money. Let's see. 1,000. 1 plus fraction button. 0.04 over 4. Raised to the, what's 4 times 5? 20. Look at that. We did. We made a little bit more money. All right, how many times a year would monthly be? That means we're going to plug 12 in for n. Let's see how that affects our money. 0.04 over 12 to the 12 times 5. 1,000. 1 plus fraction button. 0.04 over 12. Raised to the 12 times 5. So we're making a little bit more. Every penny matters, right? It adds up over time. Now, weekly. How many weeks are there in a year? There are 52. You guys need to know that. So let's throw that in now. 0.04 over 52 to the 52 times 5. So let's see what that does to the money. 1,000. 1 plus fraction button. 0.04 over 52. Raised to the 52 times 5. Well, again, notice the money keeps going up. See that? It keeps increasing. So the more times you compound something, the better. Check this out daily. How many days are in a year? 365. So 1 plus 0.04 over 365. And then I'm going to do 365 times 5. Let's see how much it goes up by this time. Oops, that's 1,000. 1 plus fraction button. Oops. Fraction button. 0.04 over 365 days a year. Raised to the 365 times 5. And it did go up. 1, 2, 2, 1, and 39 cents. All right. So you notice the more times we compound something in a year, the more money we make. Now, the continuously means we can do things non-stop. Never stops. So it's better than daily. And for continuously, we're going to bring in a whole new formula. And that's this guy, right? We're going to use something called PERT. And when it says continuously, we're going to change the formula a little bit. P-E-R-T, PERT. Okay. P is a fancy way of saying original amount. Okay. And E is a special number. Now our calculators have an E button. It's above the decimal of the division sign. And E is approximately 2.718. Okay? But you don't even need to know that because we have the E button on our calculator, so we're just going to use that when we're filling it in. So let's check this out continuously. P in PERT means the original amount. So the original amount we have is 1,000. Then E means we're going to put down the number E. R is the rate, and the rate is 4%, so I'm going to put 0.04 up there. And T is time, and this question was asking us for 5 years. So now I'm going to put this in my calculator. So I'm going to type in 1,000. Now the E button is right here next to, see the 4? See there, it says Ellen, above it is blue. It says E to the second. That E just popped up, see that? And then we're going to type in 0.04 times 5. And again, it's money. 1,221 and 40 cents. So you notice money continued to go up. And this is what we're going to be working on for the next day or two. All right, so what I want to do now is go to this packet. And again, we've already done the first 2 pages, numbers 1 and number 2. What I want to do now is go to number 3. It says, the amount of money, A, in the bank account is determined by this formula. And if you notice, it's the formula we just talked about, where P is the principal, or the amount of money invested. Okay? So P and A sub 0 mean the same thing. R is the rate, N is the number of times compounded, and T is time. So let's take a look at this question. If you initially invested $1,250, how long must the sum of money be left in an account at 6% interest, compounded semi-annually? So semi-annually and biannually mean the same thing. So how much are we starting with? So you write that down first. 1,250. Parentheses. 1 plus. Now R is the rate. The rate is 6%. So you're going to put 0.06. Divided by over N. N is how many times we're doing it. Semi-annually is twice a year. There's also an N right there. So you're going to put the 2 there. Right? Now, if you invested, right, how long means we don't know what the time is. So I'm going to leave it T. Will it take you to double? So we want to double our money. So if we started, we have 1,250, we want to double it. So I'm going to times it by 2. That means I want to know when we're going to have $2,500. So now we got to find T. What would I do first to solve this? Well, I want to get the parenthesis alone, so I'm going to divide by 1,250. Okay. So these cancel. So what is 0.06 divided by 2? Right? It's going to be 1.03 to the T equals, and then this guy divided by this guy is 2. Now I just have to log this, guys. So I'm going to write the word log. The base is 1.03. 2 equals T. Right? So I rewrite it as a log. And then I just go to my calculator. Hit the math button. Scroll up the log. 1.03. And I'm going to put a 2 in there. All right, and how long will it take? Let's round to the nearest 10, right? So T would be 23.4 years. And there you go. All right, let's look at the next one now. Mrs. Cabello invests $2,000 at an annual rate of 4% annual interest, compounded continuously. As soon as you see continuously, you guys are thinking PERT. We're going to use a special formula for that. Okay, part A. Determine to the nearest dollar the amount of money she will have after 4 years. All right, how much money are we starting with? That's the P. So I'm going to write down 2,000. Then I write down E. R is the rate, so we have 4%. So I'm going to put 0.04. And T is time. Did they give us a time this time? Yes, they did. 4 years. I'm going to plug 4 in for T. All right. Now we want to round this to the nearest dollar. So we do 2,000. Again, the E button is over here by the 4 above the natural log. So I got E. And then I'm going to type in 0.04 times 4. And we want it to the nearest dollar, so that's going to be 2,347. All right, part B. Determine to the nearest hundredth of a year, okay, how many years it will take for her investment to double. All right, so we're going to still use the same question, but we want to see how long it takes to double. So we have $2,000, E, 0.04. This time we don't know the time. And we want to double our money. So if we're starting with $2,000 and we want to double that, I want to end up with $4,000. Yes. Divide by 2,000. Okay, that cancels. I get E to the 0.04 T equals 2, right? 4,000 divided by 2,000 is 2. And now I'm going to log this. Now, E gets its own log. Natural log, you don't have to put the E there because we know it. 2 equals 0.04 T. Okay, so I go to my calculator. And I wanted to get T alone, so I'm going to divide by 0.04. So, the natural log is right here next to the 4. So I'm going to do the natural log of 2 divided by 0.04. And I want it to the nearest hundredth, so it's going to be 17.33. Okay. Now we had done number 5 at a different time, so I'm going to skip over that. And now let's look at number 6. All right. Newton's law of cooling is used to model the temperature of an object of some temperature placed in an environment of a different temperature. It's a lot of temperatures. The temperature of the object, T hours after being placed in a new environment. Okay, so we have this formula where T of T is the object after how many minutes outside. Okay. T sub A is the ambient temperature. T sub 0 is the initial, and K is the decay. A pot of tea is heated to 90 degrees. A cup of tea is then poured into a mug and taken outside where the temperature is 18 degrees. After 2 minutes, the temperature of the cup is approximately 65 degrees. Determine the value of K. All right. The pot of tea is 90 degrees. Now, let's look at these 3 things. Take a second. Which one of these 3 do you think 90 degrees is, if that's the pot of tea? Okay, good. T sub 0, the initial temperature of the cup. So I'm going to put 90 where T sub 0 is. So right after the parenthesis, I'm going to put a 90. A cup of tea is poured into a mug and taken outside where the temperature is 18 degrees. All right, which one of these would 18 degrees be? That's the temperature of the surrounding area. So everywhere I see T of A, I'm going to plug 18. After 2 minutes, that's time, so that's a little t. E -2. Okay, there. How long will it take for it to be 65 degrees? That's the answer. So I'm going to do 65 equals. All right. What I want to do now is solve this and figure out what K is. What would I have to do first? And I'm probably thinking, hey, let's subtract these. So that gives me 65 equals 18. 90 minus 18, right? 72. Right, so I'm trying to clean this up a little bit. This would be -2K there. All right, now, I got to get K alone. what would I have to move first? And I hope you're thinking you need to subtract the 18. All right, so what's 65 minus 18? 47. This becomes 47 equals, this is gone, 72e to the negative 2k. Okay, next thing we need to do is divide by 72. So this cancels. I'm going to bring this up here. 47 divided by 72, right? Now that's a big decimal. So instead of writing down the big decimal, sometimes it's easier just to leave it as the fraction. So I'm going to do that, make my life easier. Equals e to the negative 2k. All right, now, once we get here, we're going to log it. So e, we use natural log. We don't have to write the e. You can if you want to. Then 47 over 72 would go there, equals negative 2k, right? And I want to get k alone. I'm going to divide by negative 2. So now I'm going to go to my calculator, right? I'm going to hit the natural log button. I'm going to put in the fraction, 47 over 72, oops. Right? And then we're going to take all that, you can hit enter if you want to, and we're going to divide it by negative 2. So I want to round this to the nearest hundredth, so it's 0.21. So that's k. All right. Next part. Using your answer from A, determine how long it will take to the nearest tenth of a minute for the cup to cool to 50. All right, so that means we want it to be 50 now instead of 65. And all the other numbers are going to stay the same. So it's going to be 18, it's 90 minus 18, e to the negative. But this time we know what k is, 0.21, and we want to know the time. So take a minute now, guys. Pause me. See if you can finish it from here. Okay. Hopefully you pause me. Let's see if you got it. 90 minus 18 is still 72. Okay. Just like last time, I'm going to subtract the 18 over first. This becomes 32 equals 72 e to the negative 0.21t. This I'm going to divide by 72. And instead of giving a decimal, I'm going to leave it a fraction. Just easier to put in the calculator. All right, bring it up here. Now we're going to do the log. So we're going to do natural log. Again, you can put the e there if you want to. You don't have to. 32 over 72 equals negative 0.21t. And then we're going to divide by negative 0.21. So that'll cancel. T equals, and it says to the nearest tenth. So let's see what we get here. So I'm going to do natural log, fraction button, 32 over 72, enter, divided by negative 0.21. And I want it to the nearest tenth, so it's 3.9. And there you go. All right, so we have one new formula. Other than that, all the other work is the same. This was a very tricky, this was a Regents question from, geez, maybe about 10 years ago now. I don't have anything this hard for homework. I basically have questions where you plug into the formula and try to get the answer. So this is way harder than your homework will be. But let's see how that goes. And we'll touch base next time. Bye, guys.